Okay. I believe everybody of you is doing great, nice, and absolutely fine. And I hope we're live finally. Okay. Yes, we are live. Okay, guys, do let me know in the live chat how are you guys feeling, okay? Yes, you will get the notes by today evening, okay? I'll definitely share all of those notes with you. Don't worry about that, man. Chill scenes, bro. Chill scenes. Okay. Okay, everyone. Hi. Good evening. I just want to know what's going on, everybody. Okay. What are the scenes that are going on with you right now, right here? Hi. Very good evening, sir. Very good evening to you too, guys. Okay, let the people join, then we'll start accordingly. Okay. I don't want anybody to miss my lecture. I don't want anybody to miss my golden points that I'll be sharing with you. When will be the special class? Special class will be from Monday onwards, okay? And tomorrow we'll have a chill conversation session, okay? Hello, take my name, Vidya. Okay, that's fine. Okay. Okay. Guys. Okay. Hi. Your hairstyle is awesome from Karnataka. Thank you, man. Means a lot. Okay. Yesterday's class was very good. Today it will be super good. It will be super. Tamil people actually say, hey, super, ah. So it will be super today. So I want everybody of you to basically like this session right now, okay? And you guys have to show me the next level energy, then only we're gonna kill the today's session as well. Okay, otherwise it's impossible. Okay, I got it, man. Thank you, means a lot. Okay. That's nice. Thank you. Okay. So. Chalo. Let's start, guys. Do you guys want me to start? Or shall I wait? Shall we have some conversation? Okay, everybody. So, what's up, everybody? This is me, Yawar Manzoor, and welcome to JEE English Unacademy. And I hope everybody of you is doing great, nice, and absolutely fine. Okay. That's very nice. Hello, sir. You're amazing. If you remember, got in touch, LinkedIn. Yeah. I remember. Yes. Okay, that's very nice. I like it, man. So, guys, let's start this session, okay? And let's kill this session. Okay, I wanted to basically ask you one thing. Yesterday, I asked you to drop a comment down below in the last lecture, okay? That what was the answer of all those questions, but only few people did. Okay, may I know why didn't you do that? This is for basics. This is from the basics, okay? You'll definitely love it, okay, guys? So today we're gonna be starting the 12th portion, that is this Fury Live, okay? The Fury Live, we're gonna be starting for the 12th portion as well. This is Electrostatics lecture number 1. And we will be talking about some charges, what this charge exactly is, okay? Where does it come from? What is the actual field of charge? How can we produce this electric charge? Okay, and what is the story behind this? Why do we study this? Every damn thing I'm gonna be sharing with you by today itself. Okay, I'm doing great. So guys, let's basically start. Okay, and this is a piece of information about me. You can just read it out. And now right now I'm teaching you people on YouTube, and we have our own platform as well. That's what we call the Unacademy's own platform, where you can basically take this plus subscription, because there are lots of benefits that you wanna get if you take this plus subscription. Okay, what you gonna get exactly from this plus subscription? That is, you will be getting the live classes every single day. You'll be getting the weekly tests, okay? And you'll be getting the structured courses that are designed by the country's top educators. Yesterday's PDF, you'll be getting it by today itself, okay? And you'll be getting the unlimited access. What is that? You can watch anybody's lecture any damn time. Everybody, share this lecture with your friends. Ask them to join this lecture as soon as possible, because we have already started, okay? And apart from this plus subscription, you can take the Iconic subscription, understand? So what are the benefits you're gonna get in this Iconic subscription? You'll be getting all whatever you get in the plus, and you'll be getting the personal guidance in this Iconic subscription. That means an educator will be given to you. If you need any sort of clarification on any damn thing, he will definitely guide you throughout your exam, throughout your journey, okay? And you'll be getting the test analysis, you'll be getting the experts guidelines, how you have to crack your JEE mains advance. That is gonna, basically you will get all of those tips, tricks, and what are all the ways you can crack that. You'll be getting all of those by experts guidelines, okay, by different experts of the country. And you'll be getting the study material, study planners as well. And you can definitely follow me on Unacademy. This is my username over there, okay? And this is my username on Instagram, Facebook, Snapchat, everywhere. If you need any sort of clarification, I'll definitely help you. You can, yes sir, Penvid, I have already increased it, okay? Fine. Now, let's move. If you take this IIT JEE Iconic subscription, okay, you'll be getting the branded notes, and that too in the hard copy, okay? We'll be sending you to your doorstep. So if you take this subscription, so if you take it for 12 months, 18 months and 24 months, then only you can grab this offer, okay? And then we have, furthermore, if you take this plus subscription offer, if you take it for 12 months, you'll be getting 2 months extension. Understand? If you take it for 24 months, you'll be getting 2 months of extension. And you can grab this offer right now, right here, okay? And most importantly, you can take this plus subscription for 12 months. You can take this plus subscription for 18 months, for 24 months, okay? The prices are listed over here. You can check it out. And for this one and for 24 months, it's mentioned over here. And if you use my code, you can definitely get the maximum possible discount. And if you use my code, you can definitely get the maximum possible discount. Definitely maximum possible discount. And this Iconic subscription, if you take it for 12 months, you will be getting 14% off. Understand? By using my code, you can get the maximum possible discount. This is the price over here for 12 months, entire 12 months. Okay? And this price is for 18 months exactly. And this price is for 24 months exactly. Use my code to get the maximum possible discount. Okay, guys? Okay, we are going to complete up to advanced level. Definitely we'll do that, okay? Because we have promised you, Unacademy JEE English has promised you already. Hey, yo, sir. Hey, what's up? What's up? What's going on? Okay, so people are joining, sir. Increase pen width. I have already increased it. You don't worry about that. Definitely you will be able to see every damn thing, whatever I write on the board by today itself, okay? Don't worry about that, man. We got no scenes, buddy. Okay. Okay, everybody do let me know in the live chat. How is your energy today? How is your energy today? Okay. Every one of you do let me know in the live chat itself. So. Come on. Yawar sir, Josh, hi as always. What is the secret? Secret is you have to be consistent, whatever the work you are doing exactly, okay? Then only you will have the high Josh, and you should have love for your goal. You should have passion for your goal. Then only you can have the high Josh. Otherwise, it is impossible. Super duper high. Okay. Okay. So guys, we have this beautiful feature on Unacademy. Ask a doubt. If you have any sort of doubt, you can just take a picture, upload it on Unacademy. You will get the answer within no time. And furthermore, these are the batches which have already started. Some of the batches have already started on Unacademy. You can definitely take the subscription if you want to increase your rank, if you want to boost your rank in your upcoming JEEs. And this is the Unacademy Combat Scholarship Test. This is happening every single week. You can basically grab this offer. You can get up to 4 crore rupees. Understand? And if you get the rank from 1 to 3, you'll be getting 1 year of IIT JEE Plus subscription for free. So if you want to basically learn on Unacademy for free, you don't have to pay. You don't want to pay any money. So for that, you can definitely go for this scholarship test. If you got the rank from 1 to 4, you'll be getting completely for free. And by unlocking this one, you can use my code. That is this one. That is this one. Yawar. Okay. Now. Okay. And this is the scholarship test. Unacademy, crack Unacademy, Prodigy. And this is a scholarship test. Win up to prizes worth rupees 11 crore rupees. This is from 14th to 15th August. Okay, you can definitely go for this one as well. And if you find any of my content as inappropriate, you can definitely report. The link is given in the description below. Okay, you can report over there. Okay, ladies and gentlemen, boys and girls, we are about to start. I want everybody of you to join and drop a thumbs up if you are having high Josh as I do. Okay, do let me know in the live chat right now. Drop a thumbs up, everybody of you. I want to see your Josh. I want to see your energy right now, right here. Okay, we are basically starting the electrostatics. What this electrostatics is, where does it come from? We're gonna be talking every damn thing. What is the real feel of electrostatics? What are the real life applications of electrostatics? I have told you previously, if you want to understand the concept from physics, you have to question yourself. Why are you understanding? Why are you studying this concept? Understand what is the reason behind that? What are the real life applications of this concept? Then only, okay? Okay, that's very nice. That's very nice. So before this, ladies and gentlemen, boys and girls, I need to tell you something about this electromagnetism, okay? What this electromagnetism exactly is. Now let's have a look over here. Let me give you the feel. Let me give you the exact feel of this electromagnetism, okay? Everybody is understanding this one. Everybody, come on. I just want to see your Josh, man. I just want to see your Josh. That's why I am here exactly. That's why I am here exactly. Okay, okay, everybody. Okay, okay, okay. Okay, okay, that's very nice. That's very nice. Ready? Yes, yes, I am exactly ready. I am exactly ready. I want you people to be ready as well. Okay, so guys, let's start this one. Let's start this one. Let's not waste our time. So I have to go with the speed of light now. Okay. Okay. So guys, see what this electromagnetism exactly is. After this, once we get to understand this one, after that, we'll come up to that electrostatics. What that electrostatics is, we'll understand that after some time. Before that, let me just tell you a beautiful story. See, you guys tell me one thing. You have completed your 11th class. I know your basics is very unclear. You have completed your 11th class. Could you please tell me one single thing? What were we studying previously? We were talking about mechanics. We had a body over here that was moving with some velocity. We were talking about its velocity, forces, accelerations. We were talking about thermodynamics, gravitation, forces between two masses and all. So this was the other physics, okay? Now we're gonna be introducing some new branch to the physics, understand? That is what we call the electromagnetism. This is one of the beautiful branches of physics, understand? You will definitely love this physics, okay? Let me give you the feel of this one. Let me give you the feel of this one. Now, you tell me one thing. You just tell me one thing. A simple question I'll basically ask you. See, previously, whenever we were discussing the gravitation part, understand, in the mechanics, we were discussing that mechanics or gravitational part. If I ask you, I have the mass over here, I call this M1. And if I ask you, I have the mass over here, I call this M2. Okay, I have two masses over here. I have two masses over here. I have two masses over here. Understand? Now, I'm asking you a simple question. What was happening previously over there? This was attracting this mass towards itself. This was attracting towards itself. Understand? They were attracting each other. Why? Because of the gravitational force. They were applying the gravitational force on each other. I want everybody of you. Yes, yes, yes. Now see. So basically, they were applying some sort of gravitational force on each other. So this we have studied previously. Now, we are basically introducing the new branch. I'm asking you the simple question right now. See, if this is a comb in my hands right now, see that comb, okay? Now, what if I do one thing? There are piece of papers in front of me. I'll place the small piece of papers over here, okay? Now, I'll rub this comb with my hair, and then I take this comb nearer to these piece of papers, and what will exactly happen? It will attract these piece of papers. Why is it happening? What is the reason behind this? What is the logic behind this? Can anybody of you tell me what is the reason behind this? What is the reason behind this? See, previously, we were talking about these forces, gravitational forces, other stuff. Now, this comb is basically attracting these pieces of papers. It is because of some force, some forces over there. It is because of that force only, understand? So can we call that electromagnetic force? Definitely yes. So in this chapter, electromagnetism, we're gonna be talking about the forces between the charged particles. Instead of masses, I'll place the charged particles over here. I'll place the charged particles over here. Understand? And we'll check the forces. We'll discuss the forces between these two parts that we'll be studying over this one. In this one, the simple example in the real life is that you have basically comb in front of you. You just rub your comb with your hair. Then you try to take it near to these small papers, understand, small pieces of paper. Then you will basically found that it is attracting these pieces of papers. It is because of the electromagnetic forces, understand? So basically what has happened over here, this comb has gained some sort of charge over here. Forget about the charge. Something this has gained from here, and because of that, it is able to create the force on small pieces of papers. And this phenomena we're gonna be studying in detail. Here, this has exactly gained some charge. Because of that charge, some force came into play. Electrical effects came into play. Magnetic effects came into play. So we have to basically deal with all of those electrical effects, magnetic effects that comes under this electromagnetism. Like in gravitation, we were talking about the gravitational force. Here, in this chapter, in this scene, we'll be talking about the electrical effects, electrostatic forces, electromagnetic forces we'll be talking about in this chapter. Everybody is understanding this one. Everybody is understanding this one. Drop a thumbs up if you are understanding this one, what I'm trying to say. Okay, so basically this is you got to feel what I'm basically trying to say you, what we're gonna be studying in this branch of physics. So this branch of physics is right now everywhere. You are using the computers right now, understand? I'm using the screen right now. It is because of this electromagnetism. This is everywhere, understand? Electromagnetism right now is used everywhere. Now see, if I say, for example, there are different number of atoms, molecules, okay? These atoms and molecules stick together. That's why I'm standing over here. This pen is in front of me, okay? Okay, so because of those electrostatic forces, because of those electromagnetic forces, these atoms and molecules stay together. Understand? This is the reason behind that. So ultimately in this branch of physics, we'll be talking about the electromagnetic forces, fields created around these charged particles. Entirely, we're gonna be talking about this one, okay? Drop a thumbs up if you are understanding this one. Do let me know in the live chat as soon as possible. Come on, man. I need to know you are understanding this one. If not, then I'll have to repeat this, okay? So this is basically the electromagnetism that we are talking about right now. Everybody do let me know. Do let me know in the live chat. Do let me know in the live chat. Come on, man. Okay, everybody. Okay, now you tell me the answer of this question. Why were those pieces of papers being attracted towards this comb? It is because of the electromagnetic force. Understand how that was created? Because this comb has basically gained some charge from my hair. Now you will say that is because of the gravitational force. I say okay, chalo, that is because of the gravitational force. Assume for a few seconds that you take this comb without rubbing with your hair, you take it nearer to those piece of papers. Will it attract? No, it will not. So when you basically rub it with your hair, then only there will be charge gained on this particle. Because of those charge, it will attract that. This will be negatively charged, and here it will be positively charged, that piece of paper. So it will attract it towards itself. So here electrical effects are coming into play. Electrical force, or we say electromagnetic forces come into play. That's what we're gonna be studying in this chapter. I hope you got the feel of this one. I hope you got the feel of this one. Yes, 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 yes. Class 11 or 12. This is for everyone. This is a Fury Live. Everybody can watch this one. I have told you this before also. This is definitely for everyone. This is definitely for everyone. Okay. Now, so this is basically the branch of electromagnetism. That is how we're going to be dealing with this one. Now, further, this electromagnetism is divided into two parts. Understand? Like mechanics was divided into two parts or three parts. We say kinematics, dynamics, or statics. Same is the case over here. We say when these charged particles are exactly at rest. If I say, for example, there is a charged particle over here that is at rest. Okay. And if I say, is this body or this charged particle is creating some sort of electrical effects, force, electric forces basically comes into play over here, electrostatic force or field is being generated over there. So what are all the scenes happening with the charge when it is exactly at rest? That we will be studying in electrostatics. So throughout the electrostatics, we'll be talking about these forces and all, but when the charge is at rest, that's why we say electrostatics. Understand, charge is at rest. And when the charge moves at that point of time, what are the phenomena that we will be studying? That comes under the electrodynamics. Here charges will be in motion, here charges will be at rest. I hope you got the feel. What we're gonna be ultimately studying is that in this electromagnetism, about the electromagnetic forces, about the fields and all. Understand, like in previously we were talking about the mechanics, velocity, acceleration, or in gravitation we were talking about the gravitational field. We're talking about the forces between these gravitational force and all. Here it will be entirely different. Understand? Here it will be the force between the charged particles. We'll have to basically play with the charged particles, electrons, protons. This all the stuff comes under this one. I hope you got the feel. Nobody can basically make you explain more than how piece of paper gets positively charged. I'll tell you that once we get done, it is because of the induction. Okay, charging by induction. The reason for this is charging by induction. If I tell you right now, I have to basically finish this at the end of the lecture. Once I get that, you will get the answer of that question. Okay, it is basically the charging by induction. When we place a piece of paper over here and this is negatively charged, this has gained the negative charge from here. If I take it nearer to this piece of paper, so basically what happens over there, the negative charge in that piece of paper will shift because this is already negatively charged. It will repel that charge. I'll tell you everything, man. Hold on. Once we end the lecture, after that you see, there will be no confusion. Okay, fine. Sambhav Kumar, I hope you got this one, okay? I'll tell you this. I'll explain this in detail, bro. This is the question that I'll answer at the end. Oh, chill scenes. Why did you delete the message? Okay. That's fine, man. I want everybody of you to basically let me know. How many lectures are there to complete this chapter? We just started, bro. Okay? Neeraj, Raghav, we just started. Don't worry about this. We'll kill every damn thing. Okay? Now, let's basically talk about this electric charge. Let's talk about this electric charge. Anybody who is having the proper definition of this electric charge? I cannot find anyone over here because there is no one who can exactly define this electric charge. To be honest, nobody knows what charge exactly is. People know what charge exactly is. What is the definition of the charge? Nobody knows about that. But see, this is the simple question. If I ask you in mechanics, what is this mass? You will say, what is the definition of this mass? Nobody knows about that. Now, if I say how this mass exactly, how it behaves, say I can tell you. Okay, mass is basically some sort of like how we exactly measure it. We know that. So how this charge is basically produced, what is the behavior of this charge? We know that, but we cannot define this charge. This is a simple concept. Just we don't know the definition. We cannot basically define it in that way, in a proper definition. If I ask you what is the length, you will say, I'm traveling from this point to that point, so this much is the length. I'm asking you what is the length exactly. So this is a fundamental property like mass, okay? This is a fundamental property. Everybody is understanding this one. I'll make you understand this one. I'll give you the proper feel. Okay, it is an intrinsic property. Fine. Okay, it's gonna be okay. Yawar sir killing it always. Okay, that's nice, Priya. Okay. Now see what exactly this charge is. See how I exactly define it. I'll define it. Charge is something which is creating the electrical and magnetic effects. Understand? This is the simple way to define it. What is that? See, I'm taking this comb over here. I'm rubbing it with my hair, okay? Now I'm taking it close to that piece of paper. So what is happening over here? It is creating that electrical effect. It is attracting this charge. It is attracting this piece of paper towards itself. So basically, this has gained the charge. Forget about this charge. See, when I basically took this comb nearer to my, when I basically rubbed this comb with my hair, this has gained something. Because of that something, this is able to attract these piece of papers. This is able to apply the force, create force on this piece of paper. So that something is basically charge. This is how we exactly define charge. Charge creates these magnetic effects, electrical effects. Everybody, okay? So this is how exactly we define the charge. Fine. So we'll basically, I'll be showing you a different number of points, like some interesting facts about this charge. You will definitely love it, okay? So that is how we exactly gonna define this charge. Now, let's move. We say charge is responsible for creating electric force. Definitely yes. So as I told you over here, I'm rubbing this. It is basically creating the electric force. Or there is the another example. If you take, for example, this. If I say, for example, there is this rod over here. There is this rod over here, and this is the glass rod. Glass rod, okay? And there is this silk cloth, okay? Now, I'm rubbing this glass rod with this silk cloth. Understand? I'm rubbing this glass rod with this silk cloth. And I'm taking the another glass rod over here, okay? This is the another glass rod, okay? I hope you are able to see this, huh? This is the another glass rod. And I am basically rubbing this glass rod also with this silk cloth. Now, finally, what I'm doing is that I'm taking this glass rod and taking this glass rod, both of these glass rods all together, okay? These are now basically close to each other. I'm taking these two close to each other. Now, what I am observing over here is that they're repelling. Understand? They're repelling each other. Why are they repelling each other? It is because they have gained some charge. Understand? There is some charge right now. Because of that charge, electrical effect is being produced over there. Electrical force comes into play. That's why they are repelling. Okay? You'll get this. Okay. Sir, tomorrow there is any class? No, tomorrow there will be no class because on Sundays we have promised you there will be no class, only chill sessions. Thank you so much for the hard working. Okay, means a lot, buddy. Means a lot. Okay, fine. So basically they will start repelling each other. So electrical effects will be basically produced over here. Or simply there is the another example, that is touching the door handle. What is that? See, if you are sitting inside any room where there is carpet, okay, like in Kashmir we have the carpets in our rooms, and there is less humid somewhere there is less humid, and if you go and touch afterwards, if you after some time, when you basically stay inside that room, after some time if you touch the door handle, that's a metallic, it will give you a shock. Understand? Electrical shock. That is what you have gained the charge. Because of that you will get that shock. So these are basically the electrical and magnetic effects. These come into play when somebody gains the charge. Understand? So I hope you got the feel of the charge. If not, do let me know in the live chat what I'm trying to say. I hope you got that. Come on. Do let me know in the live chat if you got this. Do let me know in the live chat if you got this. Then I'll move accordingly. Okay. Now comes the picture of... Okay. Now comes the picture of positive charge and negative charge. What is this positive charge and what is this negative charge? I don't know about it. Let's basically see. Let's basically understand with a beautiful example. Let's basically try to understand with a beautiful example. Okay. Let me just give you the feel. Before that, do write in the live chat that it is crystal clear to everybody. Everybody is understanding this one. Come on, people. right now, right here, do let me know in the live chat. I'll remove this glass. Is it fine without glasses? Fine, yes, yes, yes. All right, people, all right, people. Okay, so now see, I'll basically perform 2 experiments over here. I need to perform 2 experiments over here. I'll just write over here, that is the experiment number 1, and I'll just write experiment number 2. Understand? Experiment number 1, experiment number 2. This is one of the beautiful examples. You will love it. This will give you the exact feel of positive charge, negative charge. Okay? Okay. Crystal clear. Okay, okay. Finally, English waited decades. Okay. Now see. So, what is the experiment number 1 that I'm going to be doing over here? Now see. Now see. I'm doing one thing, that is, I'm taking the same glass rod over here. I'm taking the same glass rod over here. This is the glass rod. Glass rod. Okay. And there is this silk cloth. Silk cloth. Okay. I'm rubbing this glass rod with this silk cloth. Okay. This is a simple normal silk cloth. And I'm taking this another glass rod over here. Glass rod over here. And I'm taking one more silk cloth over here. Okay. I'm rubbing this second glass rod with this second silk cloth. Okay. Fine. Now, after rubbing, what I'm exactly doing is that I'm taking this rod number 1 and I'm taking this rod number 2. Fine. I'm taking this rod number 1. I'm taking this rod number 2. I'll place them close to each other. This is a rod number 1. I'll just make it with this yellow one. It will look beautiful. It will look beautiful. Beautiful. Okay. So I'm taking this rod number 1 over here. This is the rod number 1. And I'm taking this rod number 2 over here. Okay. Now, what I observed that this rod is basically repelling this rod. This rod is repelling this rod. They are basically applying some sort of repelled force. Understand? They are repelling each other simply. So I would say I'll show it like this and I'll show it like this. Understand? This happened in this experiment. So afterwards, what I did in the experiment number 2, I took the same glass rod and same silk cloth. I took the same glass rod and same silk cloth. Okay? Same glass rod and same silk cloth. I rubbed this glass rod with this silk cloth and I changed this rod to the plastic rod over here, or the rubber rod. 1 second, 1 second. Everybody is understanding this one. This is the plastic rod or the rubber rod. And I'm placing like fur over here. Fur over here. Understand? This is what exactly the scene happened. Do let me know. Everybody is understanding this one. Everybody is understanding this one. Everybody is understanding this one. Drop a comment down below. Somebody is saying why I study gold for India in Tokyo's Olympics. That's very nice. That's very nice, man. Okay. Everybody understanding this one. Show some energy, man. I want you people to show some energy. Don't only. It would be fun. Okay. Yes. Okay. Now see. This is the plastic rod and I rubbed this with a fur. What is that fur? That fur is when you basically, if you live in the cold places, you will have, you might have seen that jackets having fur from the inside, okay? So that is fur. So I took this rod, basically this rod and I placed it over here. And I took this rod, I placed it over here. Understand? Close to each other. This is the rod number 1. This is the rod number 2. I observed that they are attracting each other. They are attracting each other. From these 2 experiments, what can we basically analyze? Can we basically say it like this, that in this case, the another type of charge is being produced, then only they are repelling each other. In this case, another type of charge is being produced. That's why they are attracting each other. Different types of charge. If same charge is over here, same charge is over here, then obviously they will repel. So means, see, this force is being produced because of the charge that we have discussed previously. Understand? Because of the charge, these electrical effects are being produced. Now see, in this case, different charge will be produced. In this case, different charge will be produced. So we basically did number of experiments, not me. The physicists already did number of experiments. They found that ultimately there are two types of charges. Understand? There are two types. Positive and negative we'll define later. So they saw that there are two types of charges. From this one, see, if I'm basically rubbing this glass rod with this silk cloth, there will be some sort of charge being produced over here. I call that X. I call that X, for example. Here, it will be same X because there is same glass rod, same silk cloth. There will be same X. Understand? So, in this case, this rod will have what charge? X charge. Okay. This will have same X charge. So, when same charges are brought together, what will basically happen? They'll repel. So that's why we say same charges repel. This is the proof over here. Understand? Like charges repel each other, unlike charges attract each other. In this case, one type of charge is being produced, glass rod with silk cloth. Understand? And in this case, plastic rod with fur, another type of charge is being produced. So one type of charge, the same X that was being produced over because glass rod, silk cloth, glass rod, silk cloth. So another type of Y. So different charges, unlike charges, will basically attract each other. Everybody understood this. Why same charges are attracting each other? Why different unlike charges are attracting each other and like charges repel each other? Everybody drop a thumbs up if you understood this one. Come on. I want you people to let me know as soon as possible. Okay? I'll tell you what is this positive charge and what is this negative charge. So till now we understood that there are two types of charges. Understand? There are two types of charges. We found that with these experiments. Finally. Come on, everybody. Crystal clear, sir. I want everybody. Okay, got it. Clear. Okay, people. One second. Somebody is over here. Okay. Okay, clear. That's very nice. Okay, now see. Finally, an American scientist came. His name was something. Okay, he basically said that there are two types of charges. He called it the positive charge. He called it the negative charge. Understand? Now, people asked him, what is the reason behind this? He said, there is no reason behind this. He just gave it, these are just the names. Positive charge, negative charge. Understand? It basically gives us that feeling. The name has to be positive and negative only. Understand? This sign conventions and all. So basically, so this is just a name, positive charge and negative charge. Later on, I'll be explaining you people how a body is being positively charged, how a body is being negatively charged. Understand? This is just a name. One type of charge is called the positive charge. Another type of charge is called the negative charge. You will ask me the question, sir, which type is called the positive? Which type is called the negative? Wait, hold on a second. For that, we have to listen to something. This is a level up series, okay? If you learn physics in a beautiful sequence, then only you would be able to understand the concepts. Like initially, the guy was asking the question, why is a positive charge being created in that piece of paper? At the end, you will get to know every damn thing. His name was something, yes. Yes, Benjamin Franklin. Exactly. Yes. नाम में क्या रखा है? Come on. Ladies and gentlemen, let's move forward. Now see, there are few points that you people need to know about. Hey, till here, everybody you understood what is this electromagnetism? Why are we studying this? You got the feel of that one. Nah? Everything understood. If not, do let me know that time only in the live chat. Sir, please repeat. I'll definitely repeat it. Okay. Hello, sir. Hey, what's up, buddy? So, SI unit of this charge is nothing but we say coulomb. We say what? We say what? 3 coulomb charge, 4 coulomb, 1 coulomb of charge, 2 coulomb of charge, 3 coulombs, 4, 5, 6. Understand? This is a scalar quantity, not a vector quantity. Understand? So, this one. Charge is always associated with mass. If there is a particle it is having some charge. Understand? There is a particle. Understand? It is having some charge on it. Understand? Like this body has gained some charge. This body is having the particles. So particles has some charge. If that particle is having some charge, that will have some mass. Understand? So that's why charge will always have some mass. Keep that thing in your mind. Charge is invariant. This is one of the beautiful points that you people need to understand. I will give you the feel of this one. I will give you the feel of this one. Okay. I want to be a model engineer and educator like Yawar sir. Wish me luck, guys. Okay. I wish you luck, man. Yes. Okay. Now let me basically make you understand charge is invariant. Charge is what this exactly mean. Let me just give you the feel of this one. What does it mean exactly? Now see, guys, how do we exactly define this one? I'll make the two columns over here. I'll write the mass. And I'll write on this side that is charge. Okay. If I talk about the mass, see, charge is invariant means charge is independent of speed. It does not change if it comes in motion. Understand? What about the mass? If mass is in motion, does the mass change? Do let me know in the live chat right now. I want everybody. Okay. Everybody, I want everybody of you to let me know in the live chat. See, so basically charge, it means charge is independent of speed. Understand? Now see, if we talk about the mass, whenever any mass comes in motion, it changes. How? Let me just give you the proof. We say this m, according to this formula, m is nothing but m is equal to nothing but m naught by root of 1 minus v square by c square. What is this? This m is basically the actual mass, that is mass in motion. Understand? I'll make you understand this one. See, this is mass in motion. Understand? Or we say this is actual mass. When the body is at rest, at that time, if we measure the mass of that body, that is not the actual mass. Actual mass is when the body is in motion. That time, if we measure the mass of that body, that is the actual mass. Actual mass. Okay, definitely from this equation, mass of a body changes if it comes in motion. This is what we call the rest mass. Rest mass. This is called the rest mass. Understand? Now, if the mass of a body remains constant when it comes in motion, then this mass in motion or this actual mass has to be equal to m naught. But is it equal to m naught directly? No. There is something in the denominator itself. 1 minus v square by c square. What is this v square? This is nothing but speed of that body, speed of that mass. Speed of that mass. And what is this? And what is this? This is speed of light. Speed of light. Everybody is understanding this one. I hope everybody is liking this one. Come on, man. Show some love over there. This is one of the beautiful lectures, okay? Next level information I'm giving you for sure. I swear I'm giving you the next level information. This information, this content that I'm sharing with you right now, it is approximately from 12 or 13 books. Approximately, I have read 13 books before I make the lecture, okay? Whenever I make the lecture, from 13 books, different websites, different other materials, coaching materials, and different other stuff, different books. Okay. Okay. Now see, so in this case, I'm saying you m is equal to m naught by root of 1 minus v square by c square. Understand? Now see, mass of a body changes. If I tell you, for example, if this is a mass, I'll make it over here. If this is a mass, if this is moving in the forward direction, it will have some velocity. How much? 30 meter per second, 40 meter per second. I'll say 30 meter, 100 kilometer, 200 kilometer per hour, 300 kilometer, not more than that, okay? 30 meter per second. Now, if I put this 30 meter per second over here, let's see what will happen to this equation. So can we say m is equal to nothing but this m naught by, this will be a root of 1 minus v square. That is nothing but 30 square upon, and this will be nothing but 3 into 10 raised power 8 its square. Now you guys tell me one thing. See, 30 square into 3 into 10 divided by 3 into 10 raised power 8 its square means a very small amount, very small amount incomparable to this one, divided by very huge, very huge amount. Understand? This number by this number, this number by this number, by this is very huge number. Understand? This term will be approximately equal to 0. When this term will be approximately equal to 0, can I write 1 minus 0 as 1? This will be m naught by 1 minus 0 as 1. Root of 1 is nothing but 1 only. So m will be equal to, so this m will be equal to this m naught. So that is why in case of the normal life, we say the mass of a body remains constant. You might have seen in your kinematics, if a body moves with some velocity, little velocity, at that point of time, we say mass of a body remains constant. But in actual, mass of a body changes, a bit changes. Understand? That's why we're not able to see it, because it's moving with a little velocity, man. Now see, that's why, see, this term will be approximately equal to 0, not exactly equal to 0. So it will have some value. That's why we say mass of a body changes. Now, if anybody is moving, if anything is moving with a speed that is comparable to the speed of light, understand, at that point of time, this will have some, this quantity will have some value, because we're not at that time, like electrons are having the speed 10 raised power 6. If we put that over here, that is comparable to the speed of light. This quantity will have some value. 1 minus 0, this will have some value. Less value. If this decreases, this will increase. At that point of time, we can basically say that mass of that body changes, which is moving with a higher speed, unbelievable speed. Understand? So that's why I am saying in actual mass of a body changes, but in real life, when the speed of a body is very less, at that point of time, we say a mass remains constant, but in actual, the mass of which body changes. Do let me know in the live chat if you got the feel of this one. If you got the feel of this one. Come on, everybody of you, do let me know in the live chat if you got the feel of this one. Come on. Come on. Could you please tell me the difference between rest mass and moving mass? That is what I was explaining. Rest mass is basically, if the body is at rest, at that point of time, if you measure the mass of that body, that is rest mass. Body is in motion. That point of time, if you measure the mass of that body, that is the actual mass or mass in motion. Understand? This is what I was explaining. That keeps on changing when the body moves. Why? According to this formula, because speed is over here. Speed of that body is over here. You got the feel, you got the feel, you got the feel. Do let me know. Crystal clear, right? Everybody crystal clear in the live chat. Come on, man. When you people write the crystal clear in the live chat, it gives me the next level feeling. Seriously. I love that crystal clear word, because it gives me a nice feeling actually, because I can analyze, I can feel that my students are understanding whatever I am saying. That's why I'm asking you every single time, write crystal clear, write crystal clear. And if not, this is clear, ask me the question in the live chat. I have the guts, I have the capability to answer every single question, whatever I am teaching, okay? Because I am definitely good at physics. Come on. Come on, man. Okay. Okay. It's gonna be okay. CC, yes, CC. Clear. So, now if we talk about the charge, ladies and gentlemen, if we talk about this charge, beautiful people keep basically asking me on Instagram, on WhatsApp, sending me messages, sir, please start a course on Plus. I'll start the course. I'll complete the every damn thing over here. Okay. Now see, charge is independent of speed. If you basically let this charge move with a speed, ultimate amount of speed. Okay. Charges, electrons move with a speed of like 10 raised power 6. But this charge remains constant. Like mass changes. Mass changes whenever the mass comes in motion. So charge remains constant. Now you got the feel. Charge is independent of speed. Mass is dependent of speed. You got the feel of this one? I hope yes. Understand? That is what we call the charge is invariant. Come on. Mass changes, charge remains same. Whatever the possible speed is, it remains same. We say charge is independent of frame of reference. Yeah, what is frame of reference? Yesterday I made you understand in the kinematics when we were dealing with that. I said if this is a car, if this is a truck, this is moving in the forward direction. Here I am A, here is my friend B, this is in motion. Now, this is in person C over here, which is at ground at rest. Now, if I ask this B, am I at rest or am I in motion? According to this B, I am at rest, okay? And according to this C, I am in motion. Now, because this is saying the car is moving in the forward direction, this bus is moving in the forward direction, so I am also moving in the forward direction. I'll have some velocity. So according to this, I will have some speed. I'm in motion, understand? So now, who is correct? Both are correct. So when we take this as a frame of reference, I'm in motion. When we take this as a frame of reference, I am at rest, exactly. But this charge is independent of frame of reference. According to, like, see, I'll make you understand like this. See, whatever you take the frame of reference, the charge is going to remain same. According to this person also, if there is a charge over here that's moving, according to this person also, charge will be same. According to the other person also, there will be same charge. Okay. Okay, it's gonna be okay, okay. Let's move. I hope these are one of the beautiful properties of... Now, let's talk about in an atom. What is this in an atom? See, in an atom, what is there? There are what? Electrons. There are electrons. There are protons. There are neutrons. Understand? We say these electrons are nothing but positively charged. Arey, sorry, negatively charged. Kya ulta bol raha hu? So we say basically these electrons are negatively charged. Arey yaar. Negatively charged. We say these protons are basically positively charged. Yeah, this is just a name, bro. Okay. At that point of time, if that Franklin Benjamin had given this as a positively charged, this negatively charged, just a name, not a problem, okay? Fine. And we say these neutrons do not have any charge. Do not have any charge, okay? Everybody, fine? Okay. So, these electrons, protons, neutrons, understand? Basically, this is if I make the atom over here, if I try to make the atom chemistry people's atom, okay? There is somewhere nucleus around over here, okay? In that nucleus, we see there is protons, understand? Protons and neutrons are in the nucleus, okay? And there are electrons which are there in this outermost shell, which can basically ejaculate from this one, which can basically come out of this one, understand? Now see, we say only in an atom, it is possible that electrons can transfer, understand? Electrons can transfer in an atom. Why not protons? Because protons are present inside the nucleus, and this nucleus is applying what? On this nucleus, nuclear force is being applied. When the nuclear force is being applied on this nucleus, which is basically keeping these protons inside the nucleus only, it is not letting them to come out of this nucleus. See, inside this nucleus, there are different number of protons only, and these protons basically same charge. These are having positive charge, same charge. They are applying the positive charge. They are applying the force, repulsive force on each other, because positive repels, repulsive force, and that is a tremendous huge amount of repulsive force, and still they are not able to come out of the nucleus. Why? Because nuclear force is basically keeping them inside, so that is basically being produced by this nucleus, understand? So electrons can basically come out of this easily, okay, fine. So it completely depends upon if a body is positively charged or negatively charged. It depends upon electrons. If the electrons are transferred from that body, then we say that body will become what? Positively charged, and the body which will gain the electrons, that will become negatively charged, okay? Sir, take more classes for 2022. We are taking every single day. Okay, fine. It's gonna be okay. Fine. Everybody understood this concept? Everybody understood this concept? I hope yes. Electrons, protons, and neutrons, okay? So we can basically transfer what? We can transfer electrons. Electrons can be transferred only. Okay? Fine. Anything else? Everybody got the feel of this one? Do let me know in the live chat. Abhi ke abhi. Okay. Yes, come on. And see, if we talk about a neutral atom, if we talk about, for example, an ordinary atom, that is the perfect point. If we talk about an ordinary atom, in that case, I'll just write in an ordinary atom, number of electrons are equal to the number of protons. Understand? So they'll have the what? They'll be electrically neutral. It will be electrically neutral, that atom. Understand? And we represent the charge of an electron as negative E, SA you can basically, and that as SA you can. Yeah, whatever the sign you're gonna take, it's one and the same thing. Okay. Now let's move. Electrons can travel from one atom to the another. As I told you previously, why not protons? Because nuclear force is being applied on that protons. Because nuclear force is being applied on what? The nucleus, which is basically keeping them inside the nucleus only. Understand? Okay, that's nice. Chalo. So, now electrons can travel from one atom to another. What is this point basically meaning? That this will give us the feel of what is that body which is being negatively charged and what is that body which is positively charged. Let me just make you understand. If I, for example, make a body over here, understand, this body, if this body comes in contact with the another body for some time, if you analyze that, okay, this is uncharged. If we say this is charged or something happened over here, if the electrons are being transferred from this body to this body, we say this will become what? This will become positively charged and this will become negatively charged, which gains the electrons. That this is how we exactly define the positively charged body or negatively charged body. So this will be negatively charged. Understand? Now it completely depends upon one thing, that is the work function that I'll be explaining you in the next one. So that's why electrons can travel from one atom to another atom. This exactly explains positively charged electron, positively charged body and negatively charged body. Oh, it's okay. Please writing clear, sir. Write clear, sir. I'm taking notes. Sorry to say this. Still, I'll share the PDF. Okay, it's very necessary to take the notes and you have to make the notes of your own. That will definitely help you very much. Okay, that's very nice. Fine. Chalo. Let's move. We say charge on an atom is indivisible in nature. See, we cannot say I'm dividing this charge and I'm transferring it. No, you can only send 1 coulomb of charge, 2 coulomb of charge. It's available in fixed amount that we'll be studying in quantization of charge. So that's why indivisible in nature. You cannot divide it like the other things. Sir, please use another color. You should have told me before. Okay, fine. I'll use the white color now. Chalo. Let's move on to the next one. Charge is conserved. What is charge conserved? What does it mean? It's like we said that mass is conserved. It can neither be created nor be destroyed like matter. Okay. It can be transformed into the other form. But in case of charge, it is a bit different. Okay. Charge is also conserved. We cannot create the charge. In entire universe, charge is conserved. We cannot create the charge. We cannot destroy the charge. Okay. Okay, the electricity. Hold on just a second. I need to. Yeah. I need to mute this inverter right now. Okay, yes, it's fine. It's fine. Okay, now see, charge is basically conserved. If I say, for example, there is a body over here. There is a system. Okay, there is a system. Okay, in this system there are multiple bodies over here. Okay, this is having some charge like 4 coulomb plus 4 coulomb plus 5 coulomb plus or minus 6 coulomb, something like that. Okay, so we say if we basically shake this, they have come in contact with each other, they'll transfer the charge from inside. Okay, the internal charges can basically change, but the system, the charge of this entire system will be basically conserved. So we can say Q net of this system is nothing but that is conserved. The net charge on the system is conserved. I'll just give you the example of this. We cannot create the charge, we cannot destroy the charge. That's one and the same thing. Okay, now see, I'll give you just an example. For example, if I say just an example like this is a body over here. Okay, and if I say the charge inside this body is plus 5 coulomb plus 4 coulomb minus 3 coulomb. Okay, and after basically coming in contact with the another body, what happens over here, there is this, we got the charge on this body as like plus 4 coulomb plus 4 coulomb or plus 6 coulomb and this q. What is the net charge on this system? You guys, what is the net charge of this one? Do let me know in the live chat right now. Okay, come on, in this another sphere, can you guys tell me how much is the net charge if I call this as the system over here? We say net charge of the system. If we shake or something, we do it like that. Net charge of this system is nothing but constant. Okay, that means charge on this system is equal to the charge on this one, individual systems. Understand? Net is constant, total is constant. So we can say this 5 plus 4 minus 3, 5 plus 4 minus 3, it will be equal to nothing but this 4 plus 6 plus q. Now find the q from over here. This will be 9, it will be 6 is equal to 10, it will be nothing but plus q. So q will be how much? Minus 4. Okay, now let's move. Okay, come on. Okay, let's move further. Let's talk about this charge is quantized. Okay, charge is quantized. Everybody, people are writing 12, 16, be 10, will be minus 4 only, na? It will come over here. So q will be minus 4. Come on. Chalo. Q is equal plus NE. Yeah, that is basically the charge is quantized. That's what we're gonna need. That's what we're gonna do over here. Okay. Tell me how we are supposed to do this one. Come on. What is this charge is quantized? Charge is quantized means you can have 1 coulomb of charge, 2 coulombs of charge, 3 coulomb of charge. You can transfer the charge in a fixed amount, 1 coulomb, 2 coulomb. You cannot transfer 1.5 coulomb. Understand? This is basically charge is available in integer multiples. Understand? I'll just write charge is available in integer multiples. Understand? Everybody? Come on. Now see, charge is available in integer multiples means you can have plus like 1 coulomb of charge or minus 1 coulomb, minus 2 coulomb, minus 3 coulomb. Understand? You can have 4 coulomb, 10 coulomb, 15 coulomb. Understand? You cannot have 3.5 coulomb, 6.5 coulomb. Understand? So that is what I'm trying to say. It is available in fixed amount. You can transfer this charge in fixed amount. Understand? Okay. How much is the charge on an electron? Come on, I want everybody of you. Tell me, guys. Do let me know in the live chat right now itself. Thank you, sir, for increasing intensity of marker. Okay. Chalo. So basically, this is not possible. Now, see, there is a formula. It is mathematical form is nothing but that is Q is equal to plus minus N times of E. Where Q is what? Q is the charge. Understand? Charge on that particle. Understand? N is what? N is number, integer, understand? Integer 4, 5, 6, 7, 8, 9, 10, and E is the charge on an electron. So this is the mathematical form. That's what is this basically saying? Charge is quantized. If you want to find the charge on any of the particles, that is integer multiple of this charge. Understand? Charge on an electron. Integer multiple of charge on an electron. That is 5 coulombs, 6 coulombs, and can be 1, 2, 3, 4, 5, 6, 7, 8. -1, -2a, ऐसा कुछ. ठीक है? Yes, everybody. Fine. चलो. ये समझ आ गया. Charge is quantized. Simple में charge is quantized. It is nothing but you can have fixed amount of charge, okay? You cannot have 3.5, 4.5 like you ask for something else. Okay, chalo. Can you guys solve this question? How many electrons are there in 1 coulomb of negative charge? Come on. Tell me. Do let me know what is the answer of this question. You can use this formula only. In order to solve this question, you can use this formula only. Q is equal to n times of E, plus minus n times of E. So here, you have to find what? How many electrons are there? You have to find this number, integer, how many electrons are there. So n is equal to Q upon E. Understand? So Q, how many electrons are there in 1 coulomb of charge? Means 1 coulomb is given, Q is given. That is 1 coulomb of charge. And charge on an electron, that is what? 1.6 into 10 raised power minus 19 coulomb. Understand? Now you can solve this one, how much it will be exactly. You can take it over there. Tell me in the live chat, 6.25 into 10 raised power 18. Solve the next question as well. Come on. I want everybody of you to basically solve this next question. So can we just write it over here? Can we just write how many number of electrons we need to charge a body by 8 into 10 raised power minus 18 coulombs? Understand? If we are supposed to charge a body, there is a body over here. If we need to charge that body by this much amount, how many electrons do we need to supply to this, or how many electrons do we exactly need? That is the question over here. Can you guys tell me how to solve this one? Simply use this one. Q is equal to n times of E. So how many number of electrons? That is, we need to find number of electrons, n. So n is equal to Q upon E. Understand? So what is Q? Q is given over here, that is 8 into 10 raised power minus 18. We have to charge that body by this much amount. So it will be nothing but 8 into 10 raised power minus 18 upon. So it will be 1.6 into 10 raised power minus 19. Can definitely solve it. So it will be 8 by 1.6 into. It will go over there. So this is 10 raised power 19. It will become 10 raised power 19. This is 10 raised power 18. So it will be 10 raised power 1. So that is 10. So it will be approximately equal to 50. Come on. Yes, 49.9. That's very nice. Everybody is understanding this one. Do let me know in the live chat. Come on, man. Come on, everybody is understanding this one. Okay, it's already 7:10. We have to finish by 7:30 itself, okay? Fine. Let's move. Mass change while transferring of electrons. As I told you previously, when there is charge, it will have mass. Understand? So, for example, if I say this is a body, if this is a body, you are transferring electrons to this body, or you are extracting the electrons from this body. That means, see, you are supplying the electrons to this body. This electron will have mass. If I say this body will have 10 grams of mass, so you are supplying the electrons to this body. So it will have, this charge is having mass. So you are increasing the mass. Now, if this is a body, 10 gram, if you are taking the electrons from this body, you are decreasing the mass. Understand? So mass changes while transferring of electrons. Everybody. No love sir class today. Love sir's class is there. Love sir's class is there, I guess. I need to check. 1 second, I need to check. Do we have love sir's class? Yeah, we have love sir. Okay, it's on 9th August. What is today's date? 7. Okay. It has been rescheduled, okay? Okay. Fine, then it's fine. We can take more time. We can definitely take more time. Okay, then it's fine. We can have the conversation session after this one as well. Okay, now let's move. Accelerated charge radiates energy. These are the golden points that I'm explaining you. How many people are live right now? Okay, come on, man. Yes. Chalo. Accelerated charge radiates energy. What does it mean? See, if I'm saying over here, I have got the charge, okay? It is at rest, velocity 0. What is gonna happen? It will create the electric field around it. We'll talk about the electric field after some time, but for now, you can just have this information in your mind. These are the different number of points. That's what I want you to be able to grasp all this knowledge, understand? Okay, so if the velocity is basically 0, if this is at rest, that means at rest, we say it will create electric field only. So, okay, so this is a charge. If I say over here, for example, this Q, it will create the electric field around it, okay? If you go in that electric field, it's going to eat us up. Okay, fine. So then we have the next one. If this charge is moving with some velocity that is but constant velocity, in that case, what is gonna happen? There will be the electric field and there will be the magnetic field. Understand? Both of these. Now, if this charge, if we say velocity is not constant, that means this is accelerating. In that case, what is gonna happen? There will be electric field, there will be magnetic field, and it radiates energy. Radiates energy. See, we'll be basically discussing all of these three facts in the upcoming time. This we'll be mostly probably will be dealing with this stuff after 3 lectures or 2 lectures, and this in the upcoming chapter, this also further. Okay, till then you can have this knowledge, you can grasp this knowledge. Exactly. Okay, fine. Now let's move. Work function of a body, one of the most important points. Okay, work function of a body. What is work function of a body? Now see, if I say, for example, I have a body over here, understand? If there is a body in front of me, now if I want to extract electrons from this body, understand? If I want to extract electrons from this body, and this body is not letting me to extract the electrons from itself, that means I say it is work function is more. Work function is more. Understand? Understand? So this is basically the body which is having more work function, it will have more electron affinity. Electron affinity basically tells us how much amount of energy do you need, minimum energy do you need in order to extract the electrons from any body. Understand? Some bodies, for example, if I take the another body close to this body, at that point of time, if this one has the more electron affinity, or if this body has the more work function, then the electrons will transfer from the other body to this body. Understand? I'll make you understand. If I say this is a body A, this is having the work function of WA, okay? And if I say this is the body B, this is having the work function of WB. Understand? This is B, okay? If I say work function of, one second, if I say work function of this A is greater than work function of this B, that means this body will not allow its electrons to go out of this. So if they come in close to each other, so they will basically start shifting the electrons. So from where to where the electrons will shift? Which one is having the body which is having less electron affinity, the body which is having less work function, so electrons will shift from here to here. Understand? So this is the scene over here. I hope you got the feel of this one. Come on. Everybody is understanding this one. I hope, yes, everybody is loving this one. So this is the scene. Let's move on to the next one. Now, we need to charge a body. How to basically charge a body? Time to charge a body. Exactly. Fine. Fine. Come on. Come on. Let's have a look on this one. So time to charge a body. How can we basically charge a body? Till now we were basically talking about different facts about the charges, what exactly charge is. Now the time came when we are supposed to charge the body exactly. So we have to basically charge the body. There are three ways we can basically charge a body. First one is by friction. That means we call this as by rubbing also. By rubbing also. If we rub two bodies, we can charge the body. Like I was giving you the example previously, rubbing a glass rod with the silk cloth, rubbing the comb with my hair. This was getting negatively charged. Okay, this is by rubbing. So first of all, we'll rub both of these bodies, understand? So they'll shift the charge, they'll transfer the charge. It depends. The body which is having, which is uncharged, that will gain the charge, or the body which is having, this is the more appropriate point, the body which is having less electron, which is having more electron affinity from that, or the body which is having less electron affinity, the electrons will shift from that body to the body which is having more electron affinity. If I say, oh, 1 second, I need to switch this off once again. 1 second. So what is the logic behind over here? If I say this is having the work function, this one, and this is having the work function, this one, understand, WFA, WFB. If I say WA is greater than WB, understand? So in that case, the electrons will shift from this body to this body by rubbing. Okay. See, the simple and the common example, we can take this one, rubber rod with a silk cloth. I'm taking this rubber rod over here, a rubber rod, and this is a silk cloth. Silk cloth. In that case, this is having the less work function, this is having less electron affinity. So this will basically, the electrons will transfer from this body to this body. So in that case, this will be positively charged and this will be negatively charged. The body which is gaining the electrons, because electrons are having the negative charge. So it will be negatively charged and this will be positively charged. So we say from this to this, electrons will shift and this will be basically negatively charged, this will be positively charged. And if we rub the glass rod with silk, that we have already done before, in that case, what's gonna happen? This one, understand? Ye wala. Fine. Okay. Conduction we'll discuss. Conduction, we are coming upon that. Induction, we are coming upon that also. Chalo, let's move on to the induction only. Chalo, conduction, let's talk about the conduction first. Okay, what was the case previously we were discussing? That is the by friction, by rubbing. In this case, conduction, what you are supposed to do, you have to let the two bodies come in contact with each other only. You don't have to rub, okay? When two bodies come in contact with each other only. It is when two bodies come in contact with each other only. Understand? You can take any example, okay? I'm taking this rubber rod over here, and this is, I'm taking the another one, that is the metallic rod over here. So I'll say this is negatively charged, this is negatively charged. Okay, these are coming in contact with each other. Afterwards, what's gonna happen? If I say more electrons are over here, this is having more negative charge. So it will basically, they will basically separate these two charges. They will basically send this charge, or anybody you can take, okay? So finally, what's gonna happen? The charge will be equally distributed. It completely depends if the two rods are basically equal in size and all, or if we take simple in general, two examples. This is one rod, this is one body. They come in contact with each other. This is uncharged body and this is charged body. When they come in contact with each other, it starts sending the electrons from here. Understand? So the charge will basically shift over here. This will get charged. Now it completely depends upon if they are having same size, same material, everything is same. So they'll be equally charged then. Understand? If this is neutral or this is uncharged, we say this is nothing but charged. This is charged. we say this is nothing but uncharged. Okay, so electrons will shift from here to here, or we say this is neutral. Electrons will shift from here to here. Now we will ask, will equal amount of electrons be shifted to here? The same will remain over here, the same will remain over here. It completely depends upon the material and other stuff as well. Come on, everybody. Does the cloud get charged? What is cloud you're talking about? Everybody. Can non-metals charge by conduction? You're talking about this one. Yes. We are sending here this. I took the plastic rod, that rubber rod, and this I took the metallic rod. Understand? They come in contact with each other. Not equally if the two bodies are different materials. Right, sir? Yes, that's what I was exactly talking about. Bodies having same material, same size, same shape. If that is the case, then they will be basically equally charged. Okay, let's move on to the next one. That is charging by induction. What is this charging by induction? This is one of the beautiful points. And after this, I will be answering that point exactly. Okay? Okay? After this, I'll be answering that point which I exactly told you previously. That one, what I was explaining. Why do basically the papers, small piece of papers, get attracted towards this one? Understand? Chalo, let me just give you the answer of that. See, what is this charging by induction exactly? The simple answer to this charging by induction exactly is, if I say, for example, this is a metallic sapphire over here. Okay, fine, this is a metallic sapphire. This is having the positive charge, this is having the positive, negative, positive, negative. This is a neutral. This is neutral initially. This is electrically neutral initially. Okay, number of positive charge is equal to the number of negative charge over here. Now I'm asking you to take a rod which is positively charged, which is positively charged. In this case, charging by induction, you don't have to take the rod, you don't have to basically touch both the bodies, or you don't have to rub these bodies. Let me just give you the example. One second. See, this is basically being attracted. Sorry, when I basically took this rod nearer to this metallic surface, what is gonna happen? Metallic sapphire, what's gonna happen over here? See, this is having positive charge. Here also this is having positive charge. So I already told you, unlike charges basically attract each other and like charges repel each other. In that case, if I say, for example, this negative charge will be what? It will be attracted towards this one, and this will basically shift. We can say basically after this, what's gonna happen is that, so this is the rod, positive charge, positive charge, positive charge. And if we talk about this metallic sapphire, so this will be the positive charge. Sorry, this will be the negative charge over here. So this will be the negative charge on this side, negative, 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 and the positive charge will be on the either side. Why? Because this will be basically getting reflected, or this will attract this one. When this rod, this is having positive charge, when this attract with the negative charge from inside the sapphire, so automatically it will seems that they will get shifted from this side and it will get shifted from this side. So still this is electrically neutral. Understand? Now what after that, what we are supposed to do is that you do the earthing. Okay, as earth is having the ultimate amount of electrons, so this will basically send the electrons from here. Okay, when this sends the electrons from here which are having the negative charge, so it will kind of kill all of these positive charge, and this sapphire will become obviously electrically negative. It will become negatively charged. Understand? So these electrons will come over here, so this will become neutral, kind of neutral from this side. So ultimately what is remaining on this side, on this sapphire, that is the negative charge. So we can remove this rod, we can remove this one, and we got the sapphire as that is negatively charged. So this is basically charging by induction without touching the rods, Yeah, there is no chemistry class today. No, there is no chemistry class today. Okay, so this was all about this. Tired, bro. Come on. So this I made you explain already. By earthing I made you explain over there also. So now you can basically definitely join the Plus platform, where we basically take the live classes, we take the weekly tests, we take the structured courses, we take the unlimited access. Okay, if you take this subscription, you'll get the unlimited access, and you'll get the personal guidance for sure. You'll get the test analysis, experts guidelines, study material, study planners. Okay, and in the Iconic subscription, you get this personal guidance and all the benefits you get. You basically get that in Plus. Understand? And this one. Now you can definitely follow me on Unacademy. This is my username over there. Okay. Okay. Sleep soon. Chalo, this is my username over there. You can definitely go for this one, and this is the Iconic IIT JEE Iconic subscription. And for brand new notes, and you can take this for 12 months, 18 months, 24 months, and then only you will get this offer. And further moving, we have this Plus subscription offer as well. You can buy this 12-month subscription for and get the 2 months extension. You can get 24-month subscription and get the 2 months extension. This is the Plus subscription offer. You can grab it right now. So you can take this Plus subscription for 12 months, for 18 months, for 24 months. Okay. So by using my code, you can get the maximum possible discount. By using my code, you can get the maximum possible discount. This code. Okay. Fine. And by taking this Iconic subscription, you can basically, you can take this for 12 months. You can take it for 18 months. You can take it for 24 months. The prices are listed over here. The prices are listed over here. The prices are listed over here. Okay. Now, these are the batches which are running in Unacademy right now. Already started some of the batches. Some will be starting very soon. So you can take this. At the end, I'm saying thank you to everybody of you. It was nice interacting with you. So chill scenes. I need to leave right now. So all of you, thank you so much. It was nice interacting with you people. So chill scenes. I am very tired today. I need to go. See you guys in the next lecture. I don't know if you have chemistry class. I guess that is cancelled.